For experiment 1A, the hydrogens and oxygens have polar charges, and this leads to the hydrogen wanting to bond with the oxygen, which is hydrogen bonding. The hydrogen bonding leads to cohesion, and cohesion is when water molecules stick to other water molecules. In experiment 1B, we determined that the hydrogens and oxygens have polar charges between the two, and this leads to the hydrogen wanting to bond with the oxygen, which is hydrogen bonding. Since the water is part of cohesion, the water molecules stick to each other, creating surface tension. And because of this surface tension, the staple in the paperclip can float if you do not break the surface tension when putting it in. For experiment 2, we determined that the hydrogens and oxygens have polar charges between the two, and this leads to the hydrogen wanting to bond with the oxygen. This is hydrogen bonding. The strength of cohesion is what the experiment was testing. Since the water has a stronger cohesion with 40 drops on the penny compared to the cohesion of the oil with 14 drops. For experiment 3, we determined that the hydrogens and oxygens have polar charges between the two elements. This leads to the hydrogen wanting to bond with the oxygen, which is hydrogen bonding. The cohesion of the water is strong because the pepper floats on the surface of the water, and when the surface tension is disrupted by the toothpick and the hydrophobic material, aka soap that is on the toothpick, comes in contact with the water, it moves out and pushes the pepper to the side of the cup. In experiment 4A, we determined that the hydrogens and oxygens have polar charges between the two elements. This leads to the hydrogen wanting to bond with the oxygen. This is hydrogen bonding. The way that the molecules are locked in place in a solid, and in a liquid they are touching but with loose bonds, and not touching at all in a gas. These are all showing the density of molecules in a substance. In experiment 4B, we determined that the hydrogens and oxygens have polar charges between the two elements. This leads to hydrogen wanting to bond with oxygen. This is hydrogen bonding. The ice floats because the more densely packed water molecules in a solid compared to the ones in the liquid form. In experiment 6, we determined that the hydrogens and oxygens have polar charges between the two elements. This leads to the hydrogen wanting to bond with the oxygen. This is hydrogen bonding. The water uses adhesion to stick to the string, and they go towards each other naturally through cohesion when the water slowly moves down other water molecules to get to the bottom. In experiment 7A, we determined that the molecules in the water are polar, and the molecules in the salt are opposite or non-polar to the water. Since they are opposite, they mix. The water is the solvent, and the molecules in the salt are hydrophobic, and they disappear. In experiment 7B, the molecules in the water and the oil are non-polar to each other, and because of this, they don't mix. They do not mix because the oil molecules are hydrophobic, and since they are hydrophobic, it means that the water will not be able to penetrate the oil. In experiment 8A, the temperature of the boiling water doesn't change because the water has reached the heat capacity. The water stays this way because the bond between the water, which is cohesion, is unaffected by the heat capacity.
Spread the ethanol.
Spread the water.
Spread the water.
Which one takes more time to evaporate? I'm going to go with ethanol. In experiment 8B, the molecules in the ethanol are polar, and so is the water. The cohesion between the ethanol is stronger than the water, so it takes more time to evaporate.